We'll start in a minute. We'll continue with solving quadratic equations by the quadratic formula today. We'll pick up from yesterday the directions on these problems are to first use the discriminant b to the second minus 4ac to classify the solutions and then find the solutions. So we're down to this example on the bottom, 49a to the second minus 84a plus 36 equals 0. So just a couple of reminders. This is the standard form for this quadratic equation. And when you determine what the values a, b, and c are, it has to be in standard form if you want to make sure that they match correctly. So in this one, lowercase a is equal to 49. It's the coefficient of the squared term. Lowercase b is the coefficient of the linear term. So the a term, the value of b is negative 84. And c is the constant 66 or 36, positive 36. Okay, so we'll use the quadratic formula. We're going to use the discriminant to classify the solutions. Okay, so b to the second minus 4ac, this is equal to the number negative 84 squared minus 4 times 49 times 36. Well, with a high-powered calculator, you'll find that this comes out to 0. So the number negative 84 squared is positive because you're squaring a negative. And then when you subtract 4 times 49 times 36, you just get 0. So you can verify that with your TI-30. Okay, so if the discriminant is 0, that means there's one repeated solution. And the solution is a real number. So one repeated real solution is what we get. Okay, so if we use the quadratic formula, capital A, I'll just remind you of the quadratic formula. Capital A equals negative b plus and minus the square root of the discriminant, which is b to the second minus 4ac, all divided by 2 times lowercase a. So A is the negative of -4, which is positive 84. Did I say that right? The negative of -84 is positive 84, plus and minus the square root of the discriminant, which is 0, all divided by 2 times 49. So this is plus and minus the square root of 0. Well, we just get one solution, as we already know. So you can write this as 84 over 98. And then you can write this in lower terms. 42 over 49. And it can be written in lower terms still because 7 goes into both of those numbers. 42 is 7 times 6. 49 is 7 times 7. And the 7's canceled. So the one solution is 6 over 7. This equation could also be solved by factoring. It turns out that this is a perfect square trinomial. So I'll just write down what the two factors are. The two factors are identical since it's a perfect square trinomial. So one factor is 7a minus 6. And the other one is the same, 7a minus 6. And you can verify by multiplying those two binomials that it's equal to the original trinomial. Okay, we'll look at some other examples of solving quadratic equations with the quadratic formula. Okay, so here's the quadratic formula. Try to memorize this. If you don't memorize it, at least know how to solve a quadratic equation using the completing the square method, because the completing the square method always works. Okay, so before assigning lowercase a, lowercase b, and lowercase c, you have to make sure that it's in standard form first. So a is the coefficient of x squared. So a is 4, b is -3, and c is +2. Okay, so x equals the negative of -3 plus and minus the square root of the number -3 squared minus 4 times 4 times 2. All of that is inside the square root. And then we divide by 2 times 4. Then we just do the arithmetic. The negative of -3 is 3, plus and minus the square root of some number in the denominator. 2 times 4 is 8. Okay, so inside the square root, the number -3 squared is 9, and we're subtracting 4 times 4 times 2. We're subtracting 32. So for this one, the discriminant is negative. So that means the solutions are non-real. So x equals 3 plus and minus the square root of -23, all divided by 8. And 3 plus and minus. And then the way that we simplify the square root of -23, think of that as the square root of positive 23 times the square root of negative 1. So we can write the square root of positive 23, but we replace the square root of negative 1 with I, and then we divide all of that by 8. Okay, in the next example, in this equation, we have negative 6x squared plus 5x plus 3 equals 0. So this time, A is negative 6, B is 5, and C is 3. So A is negative 6, B is positive 5, C is positive 3. Okay, I mentioned before, yesterday I mentioned this, if you start out with a quadratic equation in standard form, and if the coefficient of the squared term is negative, well, you don't have to leave it exactly in that condition. You can multiply every term on both sides of this equation by negative 1 so that the coefficient of x squared is positive instead of negative. The solutions to the two equations will still be the same, but the arithmetic will be easier, in my opinion, if the coefficient of the x squared term is positive instead of negative. So I'm going to do that. I'm going to multiply every term on both sides by negative 1. You don't have to do that if you don't want to. But when we multiply every term on both sides of the equation by negative 1, we get 6x to the second minus 5x minus 3 equals 0. And then we'll use A equals 6, B equals negative 5, and C equals negative 3. And then we'll use the quadratic formula with those numbers. So x equals the negative of negative 5 plus and minus the square root of the number negative 5 squared minus 4 times 6 times negative 3. All of that is in the square root. And we're dividing by 2 times 6. Okay, then be careful with the arithmetic. The negative of negative 5 is positive 5, and then plus and minus the square root of some number, and then the denominator is 12. Okay, so inside the square root, the number negative 5 squared is 25, and we're subtracting a negative number. We're subtracting 4 times 6 times negative 3. Okay, so 4 times 6 times negative 3 is negative 72. So it's 25 minus negative 72. Okay, in the next step, we write x equals 5 plus and minus the square root. Well, 25 minus negative 72 is the same as 25 plus 72. And let's just go ahead and write it as positive 97. And this is all divided by 12. Okay, the two solutions are real numbers, two different real solutions. And the square root of 97 cannot be simplified any further than that, so those are the two solutions. Okay, in the next example, on this one, 5x to the second minus 5x minus 4 equals 0. So in this one, A is 5, B is negative 5, C is negative 4. So we apply the quadratic formula. So x equals, we're solving for x equals the negative of negative 5 plus and minus the square root. Inside the square root, we have the number negative 5 squared minus 4 times 5 times negative 4. And this is all divided by 2 times 5. Then do the arithmetic. In the numerator, the negative of negative 5 is 5. And then plus and minus the square root of some number. In the denominator, 2 times 5 is 10. So inside the square root, the number negative 5 squared is positive 25. And we're subtracting a negative number again. So we're subtracting 4 times 5 times negative 4, which is negative 80. So it's 25 minus negative 80. Okay, so we get x equals 5 plus and minus the square root of 105. 25 minus negative 80 is the same as 25 plus 80, which is 105. Okay, the square root of 105 cannot be simplified any further, so this is as far as we take it. But let's practice writing the solutions separately, because you have to know how to do that too. So one of the solutions is 5 minus the square root of 105 divided by 10. And the other solution, x equals 5 plus the square root of 105, all divided by 10. Well, we'll just keep doing more examples. I know this probably isn't very fun, but you get better with practice. Okay, solve the following equations by using the quadratic formula. Okay, this is in standard form. 4x squared plus 6x plus 1 equals 0. So it's already in standard form, so we can identify A. A is 4, B is positive 6, and C is positive 1. Okay, so we write x equals the negative of 6, or negative 6, plus and minus the square root of 6 to the second minus 4 times 4 times 1, all divided by 2 times 4. Okay, so we get in the numerator negative 6 plus and minus the square root of 36 minus 16, all divided by 8. And 36 minus 16 is 20. So we get x equals negative 6 plus and minus the square root of 20 divided by 8. The square root of 20 can be simplified. So think of the square root of 20 as the square root of 4 times the square root of 5. And we simplify the square root of 4 to 2, and then write the square root of 5. We can simplify further, and we should. If you're working in Newton and encounter this one, it will expect a simplified answer. Every term in the numerator has a common factor of 2, and the denominator also has that same common factor of 2. So, in other words, when you look at -6 and 2 times the square root of 5 and 8, the greatest common factor of those is 2. So out of the terms in the numerator, I'm going to factor out 2. And when I factor 2 out of those, on the inside of the brackets, I'll have -3 plus and minus the square root of 5. And then in the denominator, I'm going to replace 8 with 2 times 4. Okay, whenever you're reducing a rational expression or a fraction to lower terms, the only time you could do it is when both the numerator and denominator have a common factor. So the numerator has a factor of 2, so does the denominator. So 2 divided by 2 equals 1. And so I'll squeeze in over here the solutions. -3 plus and minus the square root of 5, all divided by 4. Okay, another example. Solve 9x squared plus 12x plus 4 equals 0. This is already in standard form. So A is 9, B is 12, C is positive 4. Okay, so the quadratic formula, x equals -12 plus and minus the square root of 12 to the second minus 4 times 9 times 4, all divided by 2 times 9. Okay, then do the arithmetic. So we get -12 plus and minus the square root of some number divided by 18. 12 to the second is 144. And we're subtracting 4 times 9 times 4, or 36 times 4, which is also 144. Okay, so that means the discriminant is 0, and when the discriminant is 0, there's just one repeated solution. So we get x equals -12 plus and minus the square root of 0 divided by 18. I'll go into a little more detail that might, if there's some question about why we say that there's a repeated solution, one repeated real solution. Well, let's write one of the solutions as x equals -12 minus the square root of 0 divided by 18. And the other solution, x equals -12 plus the square root of 0 divided by 18. The square root of 0 is 0, and if you subtract 0, that in effect has no difference than when you add 0. So there's just one solution, -12 over 16, and then we write it in lowest terms. So it's just -2/3 in its lowest terms. Okay, so just another thing. We started out with this in this equation in standard form. Notice the greatest common factor of all three terms is 1. Since the discriminant is 0, that means that this is a perfect square trinomial. So in general, when solving a quadratic equation using the quadratic formula, if the discriminant is 0, then one of two things must be true. Either the trinomial is already a perfect square trinomial, or it is a constant multiple of a perfect square trinomial. So that's a little fact that might be useful. Okay, let's work on the next one. 2x to the second plus 8x plus 9 equals 0. So I see that there's a small number of people watching. So why don't you answer me this? If I give you a couple of minutes, will you type in what you get for the answers? So you can respond to that question immediately. If I give you a couple of minutes to work on this, can you at least tell me what, if you don't want to type in the actual numbers, you could tell me what kind of solutions they are or how to classify them. The options are 2 real numbers that are solutions, or 2 non-real solutions, or 1 repeated real solution. So I'll wait a few seconds for you to reply by typing in a comment, such as, yes, I will work on this for a couple of minutes, and then type in the solution. Or if in a few seconds I don't get any comments, then I'll just proceed. Okay, no takers, so I'll just go ahead and solve this using the quadratic formula. In this one, A is positive 2, B is positive 8, C is positive 9. So the quadratic formula, x equals negative b, so negative 8, plus and minus the square root of b to the second minus 4ac. So b is 8, so 8 to the second minus 4 times 2 times 9, all divided by 2 times a, or 2 times 2 in this case. Okay, then we do the arithmetic. So we have x equals negative 8 plus and minus the square root of some number, all divided by 4. Okay, inside the square root, 8 to the second is 64. And we're subtracting 4 times 2 times 9. That's the same as subtracting 8 times 9, or minus 72. This time the discriminant is negative. So negative 8 plus and minus the square root of negative 8, all divided by 4. And then we can simplify the square root of negative 8. So think of the square root of negative 8 as the square root of 8 times the square root of negative 1. And as usual, we replace the square root of negative 1 with I, but also as usual, we will simplify the square root of 8. So I'll write part of that down, not the complete solution, or not the simplified solution yet, but a partial simplification. So in the numerator, negative 8 plus and minus the square root of 8 times I, all divided by 4. And then simplify the square root of 8. Okay, so the largest factor of 8 that's a perfect square is 4. 4 times 2 is 8. So we'll write down some detail. Negative 8 plus and minus the square root of 4 times the square root of 2 times I, all divided by 4. So all of this extra detail, I might not have room, but we'll see what happens. Negative 8 plus and minus, the square root of 4 is 2, so plus and minus 2 times the square root of 2 times I, all divided by 4. Okay, so in the numerator, every term has a common factor of 2, and the denominator also has a factor of 2. So the greatest common factor of the number negative 8 and of the number 2 times the square root of 2 times I and the denominator 4, the greatest common factor of all three terms is 2. So I'll just divide out the 2 from all of those terms. So we get negative 4 plus and minus the square root of 2 times I, all divided by 2. Okay, that's as far as we'll take that one. Well, we're going to keep practicing quadratic formula. So if you're working on these, I know that it's probably not all that exciting, but if you're working on these, the better off you'll be, especially in the next math course after Math 1108. Okay, let's solve this by using the quadratic formula. So on this one, A is 4, B is negative 20, C is positive 25. So x equals the negative of negative 20 plus and minus the square root of the number negative 20 squared minus 4 times 25, all divided by 2 times 4. And then the arithmetic, the negative of negative 20 is 20, and then plus and minus the square root of some number, all divided by 8. Well, inside the square root, the number negative 20 squared, negative 20 times negative 20 is positive 400. And we're subtracting 4 times 25. I'll point out something when you're multiplying numbers like this. The way you multiply them can sometimes make the process easier so that you don't always have to rely on a calculator. Just the straightforward method, 4 times 4 is 16, and then 16 times 25, you can figure that out. But note first, if you multiply 4 times 25, which is 100, and then 4 times 100 is 400, so this is minus 400. Regardless of how you do it, it's going to be 400 minus 400 inside the square root. And that, of course, is 0. And so we get x equals 20 plus and minus the square root of 0 over 8. So there's just one repeated solution. So x equals 20 over 8. And we want to write it in lowest terms. So this reduces to 5/2. So one repeated real solution whenever the discriminant is 0. Okay, so what does that mean? The original equation, note that the greatest common factor of the 3 terms is 1. So since the discriminant is 0, it must mean that this is a perfect square trinomial. And sure enough, I'll just write it in factored form. You can solve this one by factoring easily enough. The 2 factors are 2x minus 5 and 2x minus 5. So since the factors are identical, you would just set one of those equal to 0 and solve for x, and you'd still get the same result, 5/2. Okay, the next example. 3x to the second minus 6x plus 4 equals 0. It's already in standard form. So we identify a as 3, b as negative 6, c is positive 4. We use the quadratic formula. So x equals the negative of negative 6 plus and minus the square root of the number negative 6 squared minus 4 times 3 times 4, all divided by 2 times 3. Okay, then the arithmetic. The negative of negative 6 is positive 6, plus and minus the square root of some number, all divided by 2 times 3 is 6. Okay, inside the square root, the number negative 6 squared, negative 6 times negative 6 is positive 36. And we're subtracting 4 times 3 times 4. So 4 times 3 is 12, and 12 times 4 is 48. So we're subtracting 48. Okay, the discriminant is negative, so that means two different non-real solutions. Okay, but we have to simplify. 6 plus and minus the square root of negative 12, all divided by 6. And then 6 plus and minus, think of the square root of negative 12 as the square root of 12 times the square root of negative 1, but let's just go ahead and replace that with I. And we can simplify the square root of 12. The largest factor of 12 that's a perfect square is 4. 4 times 3 is 12. So we can write this as 6 plus and minus. Okay, the square root of 4 is 2. So 6 plus and minus 2 times the square root of 3 times I, all divided by 6. We can simplify further because every term in the numerator has a factor of 2 which is common with the denominator that also has a factor of 2. So I'll factor 2 out of every term in the numerator. So 2 times 3 plus and minus the square root of 3 times I. And then instead of writing 6, I'm going to write it as 2 times 3 so that it's more obvious that we're going to cancel common factors. 2 divided by 2 is 1. So I'll squeeze in the solutions here. We have x equals, in the numerator, 3 plus and minus the square root of 3 times I, and that's all divided by 3. Okay, the next one, solve 5x to the second minus 5x minus 4 equals 0. It's already in standard form. So I keep repeating myself in certain ways just so that you'll be prepared for other situations that we're going to see in a minute. Okay, 5x to the second minus 5x minus 4 equals 0 is in standard form. So A is 5, B is negative 5, C is negative 4. So we apply the quadratic formula. X is the negative of negative 5 plus and minus the square root of the number negative 5 squared minus 4 times A times C. So 4 times 5 times negative 4, all divided by 2 times 5. Then it's arithmetic. It only takes one little mistake to mess everything up. So that's why practicing is a good idea. The negative of negative 5 is 5, plus and minus the square root of some number, all divided by 2 times 5, which is 10. Okay, inside the square root, the number negative 5 squared is 25, and we're subtracting 4 times 5 times negative 4. Well, we're subtracting a negative. We're subtracting negative 80s, so that's plus 80. So this is x equals 5 plus and minus the square root of 105, all divided by 10. Okay, the square root of 105 cannot be simplified, so this is the final result. Okay, the next example, we have a few minutes left. On this one, I'm going to write it down so that you can see it. Solve uh, 3 plus 5x equals 6x to the second by using the quadratic formula. So I'll give you the statement of the quadratic formula. That is the solutions to ax to the second plus bx plus c equals 0, or x equals negative b plus and minus the square root of b to the second minus 4ac, all divided by 2 times a. Okay, so we're starting out with a quadratic equation that is not in standard form. So I've mentioned a few times, before you assign values for A, B, and C, you have to make sure that they come from the correct places. So A, B, and C are the coefficients and the constant when the equation is in standard form. So that means 0 is on one side and all of the other terms are on the other side. And also make sure that the x squared term is farthest to the left, the x term is in the middle, and the constant is on the right. Okay, so in this quadratic equation, we want to make sure that we get it into standard form first. So one way to do it, there's 2 ways that you could write this in standard form. But if we subtract 3 from both sides and subtract 5x from both sides, then we get 0 equals 6x to the second minus 5x minus 3. So this is considered in standard form. But if you'd rather have the trinomial on the left-hand side, you can do that. If you want to write 6x to the second minus 5x minus 3 equals 0, that is perfectly fine. And now that it's in standard form, we can pick off the value of a. A is the coefficient of x squared, which is 6. B is the coefficient of x, which is negative 5. And c is the constant, negative 3. So we can write down the equations using the solutions to the equation using the quadratic formula. So we get x equals the negative of negative 5 plus and minus the square root of the number negative 5 squared minus 4 times 6 times negative 3. And this is all divided by 2 times 6. Okay, so arithmetic, the negative of negative 5 is 5, plus and minus the square root of some number, all divided by 2 times 6, or 12. Inside the square root, the number negative 5 squared is 25. And we're subtracting 4 times 6 times negative 3. We're subtracting negative 72. Okay, so that's x equals 5 plus and minus the square root of 25 minus negative 72 is the same as 25 plus 72, which is the square root of 97. Okay, and the square root of 97 cannot be simplified further. Well, you might have probably noticed that I did 2 of the same examples 2 times each, but that's okay. We have about 1.5 minutes left, so I'll write down one more. One more example. Find the discriminant of the quadratic equation 3x plus 7x squared equals -1. Well, in order to find the discriminant, you have to make sure that you correctly assign the values a, b, and c. So why don't we write this in standard form first? So the 7x to the second is to the left of 3x plus 3x. And then we add 1 to both sides so that the right-hand side is 0. So now we can see that a is 7, b is 3, and c is +1. So the discriminant is b to the second minus 4ac. So that's 3 to the second minus 4 times 7 times 1, or 9 minus 28, or -18. Okay, so since the discriminant is negative, the two solutions are two different non-real solutions. Okay, that's all for today. Tomorrow we'll move on to the next section, and then we're almost done with all of the materials. That's all for today. Today we're going to learn how to solve quadratic equations by the quadratic formula. But first, just a reminder, any quadratic equation can be solved by completing the square. That's what we talked about last time. But since that is the case, a formula can be derived by completing the square to solve any quadratic equation. That formula is called the quadratic formula, and it will be derived in the space below. Okay, so we have this quadratic equation in standard form, ax squared plus bx plus c equals 0. We're going to solve this by completing the square. The result, when we're finished, will be a formula for solving any quadratic equation if it's in standard form. Okay, so just like we did yesterday to solve this by completing the square, first we subtract c from both sides, so ax squared plus bx equals negative c. The coefficient of the x squared term is a, so in the next step, we're going to divide every term on both sides by a. Ax squared divided by a is x squared, and then plus bx divided by a, we write this as plus b over ax. Leave some space for the completing the square part, and that's equal to the negative of c over a. Okay, now we're going to find a number to add to both sides of this equation so that the left-hand side is a perfect square trinomial. Just like we did yesterday, now that the coefficient of x squared is 1, we take 1/2 of the coefficient of x, or 1/2 of b over a, and 1/2 times b over a is b over 2a. Then we square this number. When we square the quotient b over 2a, that just means b over 2a times b over 2a. So the numerator is b to the second, because b times b is b to the second. And in the denominator, 2a times 2a is 4a to the second. Okay, so b to the second divided by 4a to the second is what we add to both sides of this equation. So on the left-hand side, we have x squared plus b over ax plus b to the second over 4a to the second. And then on the right-hand side, we have negative c over a plus b to the second over 4a to the second. Okay, so the left-hand side is now a perfect square trinomial, which means that it's equal to some binomial squared. On the right-hand side, we're adding two rational expressions, or two fractions, and we want to write it as a single fraction with a common denominator. So let's identify the least common denominator right now. This denominator on the left is a, and this one is 4a to the second. So the least common denominator is 4a to the second. So in the next step, one of the next couple of steps, we'll have to multiply negative c over a by 1 in the form 4a divided by 4a, because in the denominator a times 4a is the same as 4a to the second. Okay, we'll do that in a few seconds. This is a perfect square trinomial. So how do we determine what binomial we have to square? Think about that. I'll start working on the right-hand side. We have to multiply negative c over a times 1 in the form 4a over 4a. Okay, so the binomial squared, the binomial has to have x because the perfect square trinomial has x squared, and x times x is x squared. So we determine what follows the same way that we did when we were using completing the square method with actual numbers. The number that follows x is the same number we get when we take 1/2 of the coefficient of x in the trinomial. The coefficient of x in the trinomial is b over a. 1/2 of that is b over 2a. So that means we're going to write plus b over 2a. So over here, let's go ahead and write this as a single rational expression with a common denominator 4a to the second. And I'm going to put the b to the second term on the left. And instead of negative 4ac, we write minus 4ac on the right. Okay, the next step, I'll just rewrite. I'll remove this stuff in the middle and write the left-hand side, x plus b over 2a squared equals b to the second minus 4ac, all divided by 4a to the second. Okay, remember what the goal is. The goal is to solve this equation for x. But now it's in a position to apply the square root property. Since the binomial x plus b over 2a squared equals b to the second minus 4ac over 4a to the second, we can apply the square root property and we get x plus b over 2a equals positive and negative square root of that entire rational expression. So inside the square root, we have b to the second minus 4ac over 4a to the second. Okay, now we're just 2 or 3 steps away from being done with this. Notice inside the square root, the denominator 4a to the second is a perfect square. So when we take the square root of the denominator, we're just going to get 2a. Okay, but I'll write down a little bit of detail. I'll just rewrite the left-hand side for now, x plus b over 2a. And that's equal to positive and negative. And then I'm going to apply the quotient property of radicals. The square root of a rational expression is equal to the square root of the denominator, the square root of b to the second minus 4ac. I think I said that wrong. The square root of the numerator, b to the second minus 4ac, divided by the square root of the denominator, the square root of 4a to the second. And as we noted earlier, the square root of 4a to the second will simplify to 2a. In the next step, I'll do 2 things at once since I'm rapidly running out of space. I'm going to subtract b over 2a from both sides and also at the same time simplify the square root of 4a to the second. It will simplify to 2a. So we subtract b over 2a from both sides. So x equals negative b over 2a plus and minus the square root of b to the second minus 4ac divided by 2 times a. So this suffices as the quadratic formula, the formula that can be used to solve any quadratic equation whatsoever. But you might see it written in a more compact way. We can write in the numerator negative b plus and minus the square root of b to the second minus 4ac, and then divide all of that by 2a, since we have a common denominator of 2a. Okay, so that's called the quadratic formula. Okay, we'll get a lot of practice using the quadratic formula here in a few minutes. But first, the number b to the second minus 4ac that's inside the square root is called the discriminant. And if you know what the discriminant is for a quadratic equation, then you can classify the solutions. And since we know about square roots of negative numbers and square roots of positive numbers and the square root of 0, then we will be able to classify the solutions to quadratic equations. Okay, so if we just think about what the discriminant is the number b to the second minus 4ac. It's inside the square root. So if the discriminant is greater than 0, which means that it's positive, then the equation, the quadratic equation, ax squared plus bx plus c equals 0, has two distinct real solutions, or two different real valued solutions. In another case, if the discriminant is less than 0, or another way to put it, if the discriminant b to the second minus 4ac is negative, well, we know that the square root of a negative number is not a real number. So if the discriminant is negative, then the quadratic equation has two different non-real solutions. And then the third case, if b to the second minus 4ac is 0, well, the square root of 0 is 0. So in that case, the quadratic equation has one repeated real solution. It's called repeated because, note, if the discriminant is 0, the square root of 0 is just 0, and negative b plus 0 divided by 2a is the same number as negative b minus 0 divided by 2a. That's why it's called repeated. Whenever the discriminant is 0, that means one of two things about the trinomial. Either the trinomial is a perfect square trinomial, if the discriminant is 0, or it could just be a constant multiple of a perfect square trinomial. Okay, you'll see that in some of the examples. Okay, we'll do some examples where we apply the quadratic formula. So here's the quadratic formula. The solutions to ax squared plus bx plus c equals 0 are x equals negative b plus and minus the square root of b to the second minus 4ac, all divided by 2a. That's what we derived. Okay, before assigning the numbers a, b, and c, you have to make sure that you pick them from the right terms. If the quadratic equation is in standard form, like this one, x squared minus 7x minus 2 equals 0, then the a is the coefficient of the x squared term. So in this case, a is 1. B is the coefficient of the x term when it's in standard form. So b is negative 7. And c is the constant. In this case, it's negative 2. Okay, if the quadratic equation that you begin with is not in standard form, or if the terms are rearranged, then it would be pretty easy to mistakenly pick A, B, and C. But if you rewrite it so that it's in standard form, then you can identify what the values of A, B, and C are. Okay, so we'll just apply the quadratic formula. X equals, according to the formula, negative b. So if b is negative 7, x is equal to the negative of negative 7 plus and minus the square root of the number negative 7 squared minus 4 times 1 times negative 2. Sorry, 4 times 1 times negative 2, all divided by 2 times 1. So now we'll just do some arithmetic. It only takes one little mistake to throw everything off. The negative of negative 7 is 7, and then plus and minus the square root of some number, all divided by 2, because 2 times 1 is 2. So inside the square root, the number negative 7 squared, that means negative 7 times negative 7, which is positive 49. And then we're subtracting 4 times 1 times negative 2. So we're subtracting negative 8. So it's minus 49. Inside the square root, it's 49 minus negative 8. So we get x equals 7 plus and minus the square root of 49 minus negative 8 is 49 plus 8. I'm going into more detail than is absolutely necessary, but that might be okay for the first 2 or 3 examples. So inside the square root, 49 plus 8 is 57. So we have the square root of 57. Okay, so the two solutions are x equals 7 plus and minus the square root of 57, all divided by 2. The square root of 57 cannot be simplified any further. So this is one way to write both solutions. But you can also write them separately. One solution is 7 minus the square root of 57, all divided by 2. And the other one is x equals 7 plus the square root of 57, all divided by 2. Okay, I would advise memorizing the quadratic formula. If you don't want to do that, at the very least, be able to solve a quadratic equation by completing the square. Because completing the square can be used to solve any quadratic equation. Okay, let's apply the quadratic formula to the next equation. This one, 3x to the second minus 5x plus 1 equals 0. Okay, this is in standard form. Standard form has one side 0, and then the trinomial, the terms in the trinomial are arranged in order. The term on the left has the largest exponent, x to the second. The middle term has x to the first, and then the constant is on the right. So we assign, or we can tell now that a is 3, b is negative 5, and c is positive 1. Okay, so we'll use the quadratic formula. X equals the negative of -5 plus and minus the square root of the number -5 squared minus 4 times a times c. 4 times 3 times 1. And then all divided by 2 times a, which is 2 times 3. Okay, then it's arithmetic. In the numerator, the negative of -5 is 5. And then plus and minus the square root of a number inside the square root. -5 squared is positive 25. And we're subtracting 4 times 3 times 1. We're subtracting 12. And we're dividing by 6. Okay, inside the square root, we just get a positive number. So x equals 5 plus and minus the square root of 13, all divided by 6. The square root of 13 cannot be simplified any further. So these are the two solutions. Okay, the next one, negative 2x squared plus x plus 4 equals 0. Well, let's use a equals -2, b equals +1, and c equals +4. So over here on the right half, I'm going to solve this equation using the quadratic formula. And then after we do that, I'll show you an alternative way to solve the same equation. Okay, so if we use a equals -2, b equals 1, and c equals 4, then the solutions are x equals -1 plus and minus the square root of 1 to the second minus 4 times -2 times 4, all divided by 2 times -2. Okay, then x equals -1 plus and minus the square root of some number, all divided by -4. Okay, so inside the square root, we have 1 squared is 1, minus 4 times -2 times 4. So we're subtracting -32. So I'll go ahead and write it 1 minus -32. And then we get x equals -1 plus and minus the square root. Well, 1 minus -32 is the same as 1 plus 32. So it's the square root of 33 divided by -4. Okay, on a written quiz or test, this is an okay answer as far as I'm concerned. But if you have a solution like this in the Newton software, it doesn't allow you to have a negative in the denominator. So how do you fix that if you have a negative number in the denominator? Well, it's not too hard. You can multiply by 1 in a special form. The form that it takes is -1 divided by -1. So in other words, if you multiply every term in the numerator by -1 and also multiply the denominator by -1, then you'll have the solutions, the correct solutions, but the denominator will be positive. Okay, so think about what happens if you multiply every term in the numerator by -1. -1 times -1 is 1. And one of the solutions involves adding the square root of 33. So if you multiply that by -1, that turns out that you're subtracting the square root of 33. Then for the other solution that we have here, we're subtracting the square root of 33, but if you multiply by -1, it amounts to adding the square root of 33. So if I multiply every term in the numerator by -1, I just get 1 minus or plus the square root of 33. But minus or plus is equivalent to plus or minus. So I can write this in the numerator, I can write it as 1 plus and minus the square root of 33. And then in the denominator, we multiply -4 by -1, and we get +4. Okay, but you can avoid that altogether right from the start. If you have a quadratic equation that's in standard form and the coefficient of x squared is negative, well, you can take care of that. You can, since it's an equation, we can multiply every term on both sides by -1 right from the start. That's perfectly legal if it's an equation. Just whenever you multiply both sides of an equation by the same non-zero number, then the essence of the equation doesn't change. The appearance will change, but it still means the same thing. So multiply every term on both sides by -1, we get 2x to the second minus 1x minus 4. 0 times -1 is still 0. Okay, so if we solve this quadratic equation, the solutions will be exactly the same as the equation above it, even though the coefficients are the negatives of each other. So on this one, A is 2, +2, B is -1, and C is -4. So we'll get started with the quadratic formula on this one. And then when we can identify that the solutions are indeed identical, then we can stop. So x equals the negative of -1, which is 1, plus and minus the square root of the number -1 squared minus 4 times 2 times -4, all divided by 2 times 2. And then x equals 1 plus and minus the square root of some number divided by 4. So inside the square root, the number -1 squared is +1, and we're subtracting 4 times 2 times -4. So it's +1 minus -32 again, but we know that 1 minus -32 is just +33. So you can see that the solutions are exactly the same. And you didn't have to go through the process of changing a negative denominator to a positive. You can do it that way if you want, but you can avoid it altogether right from the start. Okay, the next few exercises, they'll still involve solving quadratic equations, but we're also going to do something else. Okay, in these examples, it says use the discriminant b to the second minus 4ac to classify the solutions. And then once the solutions have been classified, then we find the solutions. Okay, so for this one, this quadratic equation is in standard form. The variable x is not used this time, it's the variable y. That's okay. It's still a quadratic equation in the variable y, and it's in standard form. So the value of a is 6, the value of b is -7, and the value of c is +9. So we want to find the discriminant, b to the second minus 4ac. Okay, so I'll write that, b to the second minus 4ac. B is -7, so the number -7 to the second minus 4 times 6 times 9. Okay, the number -7 squared is 49. -7 times -7. And when we subtract 4 times 6 times 9, we're subtracting 24 times 9. So we're subtracting 216. So we can see that it's going to be a negative number. So this just turns out to be -167. So how do we classify the solutions if the discriminant is negative? Well, remember in the quadratic formula, the discriminant is the number that's inside the square root. So if you take the square root of a negative number, you get a non-real number. So the solutions are, I'll go ahead and write it out. The solutions are 2 distinct or different non-real numbers. Okay, so let's go ahead and find the solutions. We've already found the discriminant, that helps. So use the quadratic formula, y equals the negative of -7, I'll go ahead and write it, the negative of -7 plus and minus the square root of the discriminant. We already computed that, the square root of -167 divided by 2 times 6. And so we get y equals the negative of -7 is 7 plus and minus. And then we know how to handle square roots of negative numbers now. Think of the square root of -167 as the square root of +167 times the square root of -1. But we will, instead of writing the square root of -1, we'll just write I. So this is 7 plus and minus the square root of 167 times I, all divided by 12. Okay, I don't think the square root of 167 can be simplified any further. And even if it can, I don't think it can, but even if it could be simplified further, if you write this on a quiz or a test paper, that would be satisfactory in this case, because it's not obvious how to simplify that square root if it can be simplified at all. I don't think it can be. Okay, let's do the next problem. Same sort of problem. N to the second minus 8n plus 5 equals 0. This time the variable is n, but it's still a quadratic equation, and it's in standard form. So in this one, a is +1, b is -8, and c is +5. Compute the discriminant, b to the second minus 4ac, b to the second minus 4ac. So this is the number negative 8 squared minus 4 times 1 times 5, which is 64 minus 20, which is positive 44. Okay, the discriminant is positive, so that means the solutions are two different real numbers. So the solutions are two distinct or two different real solutions. Okay, so let's go ahead and find the solutions using the quadratic formula. So n equals the negative of negative 8 plus and minus the square root of the discriminant, which is 44, all divided by 2 times 1. And then do some simplifying. The negative of negative 8 is positive 8. And we can simplify the square root of 44. The largest factor of 44, that's a perfect square, is 4. 4 times 11. So let's write it as the square root of 4 is 2. So it's 2 times the square root of 11, all divided by 2. And we can simplify further. Every term in the numerator has a common factor of 2, and the denominator has a factor of 2. So I'll factor 2 out of every term in the numerator, so it's 2 times the quantity 4 plus and minus the square root of 11, all divided by 2. And 2 divided by 2 is 1, so the solutions are 4 plus and minus the square root of 11. Okay, the next example, here's a quadratic equation in the variable capital A. So capital A is distinct from lowercase a. And it's in standard form, so A is 49, B is negative 84, and C is positive 36. Okay, so the discriminant, b to the second minus 4ac, that's equal to the number negative 84 squared minus 4 times 49 times 36. When you square the number negative 84, it's going to be positive. And with a high-powered calculator, you can determine that this is just 0. So you can do that if you want, or you can take my word for it. Okay, the discriminant is 0. So that means there's one repeated real solution. So there's just one solution, but we call it repeated. There is one real valued solution. Because the square root of 0 is just 0. Okay, so we can write A equals the negative of negative 84 plus and minus the square root of the discriminant. We know that that's 0, all divided by 2 times 49. The square root of 0 is 0, so that in the numerator, the negative of negative 84 is just 84. And the denominator is 98. And plus 0 is no different than minus 0. So there's one solution we just say that it's repeated. And this can be written in lower terms. Let's see, 84 is 7 times 12. 98, 7 times 14. The 7s cancel, and then 12 divided by 14 cancels, or simplifies to 6 over 7. So the repeated solution is 6 over 7. Okay, remember what is involved if the discriminant is 0. So let's look at this trinomial. The greatest common factor of all of the 3 terms is 1. So that has to mean, since the discriminant is 0, that has to mean that this trinomial is a perfect square trinomial. Which means that if you factor it, the 2 factors are identical. And this is not hard to factor. In fact, you factored things like this earlier this semester. So this is a good test, final exam review problem. Factor this. So one of the factors is 7a minus 6. The other one is identical, 7a minus 6. So we could have solved this equation by factoring. So just set 7a minus 6 equal to 0. Add 6 to both sides and divide both sides by 7. We get a equals 6/7, just like we did by using the quadratic formula. Okay, we have a few minutes left, so we'll just practice the quadratic formula until it's time to quit. Okay, this is in standard form, so make sure that it's in standard form. You won't always get examples of quadratic equations that are in standard form to start with. So write it in standard form so that you correctly identify the values of a, b, and c. In this one, the coefficient of x squared is 4. So a is 4. The coefficient of x is 6. So b is 6. And the constant, plus 1, that means c is positive 1. So the solutions using the quadratic formula, x equals negative 6 plus and minus the square root of 6 to the second minus 4 times 4 times 1, all divided by 2 times 4. Then we do the arithmetic. In the numerator, negative 6, and then plus and minus the square root of some number, all divided by 8. Okay, so inside the square root, 6 to the second is 36. And we're subtracting 4 times 4 times 1. We're subtracting 16. So we get x equals negative 3 plus and minus the square root of 20, all divided by 8. The square root of 20 can be simplified. The largest factor of 20 that's a perfect square is 4. So we can write this as negative 6 plus and minus the square root of 4 times the square root of 5, all divided by 8. And then a couple of steps, negative 6 plus and minus 2 times the square root of 5, all divided by 8. And we can write this in lower terms because every term in the numerator has a common factor of 2. 2 times negative 3 is negative 6. 8 has a factor of 2. So I'll factor 2 out of every term in the numerator, so it's 2 times the quantity, negative 3 plus and minus the square root of 5. And I'll replace 8 with 2 times 4. so that it's more obvious that we're canceling common factors. 2 divided by 2 is 1. And so our solutions, simplified solutions, are, I'll write them separately. One solution is negative 3 minus the square root of 5 over 4. The other solution is negative 3 plus the square root of 5 over 4. Okay, let's try the next one. 9x squared plus 12x plus 4 equals 0. It's in standard form. So the value of A is 9. The value of B is 12. The value of C is 4. So using the quadratic formula, we get x equals the negative of 12 plus and minus the square root of 12 squared minus 4 times 9 times 4, all divided by 2 times 9. Okay, then we do the arithmetic. X equals negative 12 plus and minus the square root of some number, all divided by 18, because 2 times 9 is 18. Inside the square root, 12 to the second is 144, and we're subtracting 4 times 9 times 4. 4 times 9 is 36, and 36 times 4 is 144. So the discriminant is 0. So we write negative 12 plus and minus the square root of 0 over 18. Square root of 0 is 0, so there's just one repeated solution. Negative 12 over 18. And then written in lowest terms, this is negative 2/3. Okay, so that means that the trinomial, since the greatest common factor of all three terms in the trinomial is 1, that means the trinomial is a perfect square trinomial. So that means we could have solved by factoring. The two factors, I'll just write here in the middle, are extracurricular work. 9x to the second plus 12x plus 4 is equal to 3x plus 2 times 3x plus 2. And if the product is 0, then we can set one factor equal to 0 and solve. So you can tell pretty much by looking, if you solve 3x plus 2 equals 0, subtract 2 from both sides and then divide both sides by 3, you get the same solution we got, negative 2/3, by using the quadratic formula. Okay, so in general, if you're taking a quiz or a test, unless the directions specify on how to solve the equation, if it just says solve the equation, you can solve it using any method that you want. If it's easy to factor, this is pretty easy to factor. You can solve it by factoring. But if you don't recognize how to solve by factoring, you can always use the quadratic formula, and you can always use the completing the square method. Okay, so we're down to just a few seconds. So we can probably solve this in 20 seconds. On this one, A is 2, B is 8, C is 9. So x equals negative 8 plus and minus the square root of 8 to the second minus 4 times 2 times 9. all divided by 2 times 2, and then negative 8 plus and minus 64 minus 8 times 9, or minus 72. Okay, we're out of time. You can see that the solutions are non-real because the discriminant is negative. Okay, tomorrow we'll move on to the next section, 9.5. That's all for today.